Dear friends, welcome to my video on quantum mechanics versus string theory. Kindly click on the CC button for subtitles. Quantum mechanics and string theory are two of the most significant theories in modern physics, each attempting to explain fundamental aspects of our universe. Their differences and potential compatibilities offer a fascinating look into the world of theoretical physics. Quantum mechanics, the foundation of modern physics. Quantum mechanics, developed in the early 20th century, is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. It introduced revolutionary concepts: wave-particle duality. This principle suggests that every particle exhibits both wave and particle properties. A cornerstone example is the behavior of light and electrons, which can demonstrate characteristics of both waves and particles. Uncertainty principle, formulated by Werner Heisenberg, it states that the more precisely the position of some particle is determined, the less precisely its momentum can be known, and vice versa. Quantum superposition and entanglement. These are phenomena where particles exist in multiple states or are interconnected regardless of the distance separating them. Quantum mechanics has been immensely successful in providing accurate predictions for a wide range of phenomena at small scales. It's the basis for technologies like semiconductors, lasers, and MRI machines. String theory, a framework for unifying physics. String theory emerged in the latter part of the 20th century as a theoretical framework in which the point-like particles of particle physics are replaced by one-dimensional objects called strings. It's a candidate for a theory of everything, aiming to address some of the limitations of quantum mechanics and general relativity, strings and extra dimensions. In string theory, particles are seen as vibrating strings. These strings can vibrate at different frequencies, explaining the particle's properties. The theory also suggests more than the familiar three dimensions of space and one of time. Unification of forces. String theory attempts to unify the four fundamental forces of nature: gravity, electromagnetism, strong nuclear force, and weak nuclear force. Solving quantum gravity. A significant challenge in modern physics is to formulate a quantum theory of gravity. String theory is one of the leading approaches in this area. Quantum mechanics versus string theory contrasts and challenges. The primary difference between quantum mechanics and string theory lies in their scope and the problems they address. Scale and applicability. Quantum mechanics is incredibly successful at explaining phenomena at the atomic and subatomic levels. In contrast, string theory aims to explain everything, including gravity, at all scales. Mathematical formulation and predictions. Quantum mechanics is a well-established theory with precise predictions that have been experimentally verified. String theory, however, is still in a developmental stage, lacking direct experimental evidence due to the incredibly high energy scales at which strings would exist. Gravity. One of the most significant issues is that quantum mechanics does not incorporate gravity. String theory attempts to fill this gap by including a quantum theory of gravity. Potential integration. Toward a unified theory. Some physicists believe that string theory could provide a deeper understanding of quantum mechanics. If string theory is correct, it could potentially explain some of the perplexing aspects of quantum mechanics and offer a more unified description of the fundamental forces of nature. Conclusion. Both quantum mechanics and string theory represent monumental efforts to understand the universe. While quantum mechanics has a proven track record of accurate predictions, string theory offers a tantalizing glimpse at a more unified picture of the cosmos. The journey to reconcile these two theories, or to find a better alternative, represents one of the most exciting frontiers in modern physics. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.